So I'm working on a white outdoor 0 turn, and this is a ZT50, so that stands for 0 turn 50 inch. And basically this thing, it runs, it drives, but the PTO wouldn't engage. And we've figured out that the PTO works because we put 12 volts directly to it. And after I jumped a few safety switches, just to bypass them, I use a little piece of yellow wire and I go in to where the switch is right here and I bypass it. This thing fired up, and when I clicked the PTO switch, the PTO engaged. So that let me know that it was this little safety switch right here that's bad. And I ended up testing that. I went here to here with my multimeter, tested for continuity, and there was no continuity in either position. So I ordered a couple of them, and that is your reverse switch. So it lets you know that your machine's in reverse. And if we come over here to the driver's side, you can read right here, it says PTO automatically disengages when both lap bars are into the reverse position. So even if one of them is into the reverse position, I guess, because I bypassed the one and I had the other one plugged in and it worked, which means that that reverse switch is good, but it was this reverse switch over here that was bad. So that's a quick fix. I just got to order parts for that. But now I'm working on this Toro, and I'm just doing a little test here. I got my battery booster supplying 12 volts to my ground and my positive, and I've grounded to the frame, and I've also grounded to the wire. My ground is good, so I tested the solenoid itself, and I have my positive lead hooked up to the positive. This is a 4-post solenoid, and you guys can see on my how to test a solenoid video, on a 4-post you have to go hot and ground, which is positive and negative. On a 3-post you only have a 12 volt positive and it grounds to the frame, so you want to make sure that you have a good ground, because a lot of times what will happen is you'll get rust underneath this solenoid and you'll get a bad ground. But basically I'm testing this with my Eliminator here, and I turn this and you'll hear the solenoid click. So that magnet is picking up in there, so we know that the solenoid tests okay. I've also tested the key switch, and I've also replaced it just to double check. The key switch tests okay. So right now I'm looking at most likely either a faulty brake switch or a faulty deck switch. So here's the deck switch. You can hear it click, but just because it clicks doesn't mean that it's actually engaging on, you know, the electrical side of things. So I'm going to have to probe the connector right there just to make sure that it is in fact working, because something's preventing 12 volts from going to the solenoid when you turn the key switch into the start position, which is the spring loaded all the way to the right. So normally that's a safety switch, and on these, you know, it could have multiple switches, but that is your deck height, and sometimes they have a switch there to make sure your deck is all the way up. So you have to check that. Either it's at the handle or it's somewhere at the deck. Other ones, they have just a deck engaged so that you can't, I think, start your machine when the blade is engaged. So you have to disengage the blade, which it is now. And you also have a brake safety switch here. But that one, by the way, that one's solved. I'm just waiting on the safety switches now. Like I said, I just use a yellow wire to bypass a safety switch. On the one video, the 0 turn, the guy says, oh, if you want to cut in reverse, just unplug your safety switch. It all depends on which position the switch is, if it's open or closed, in the down or the up position, you know, it all depends. So again, if you need a completed circuit, just unplugging them, now you're opening the circuit, which means there's an open in the circuit, which means it's not connected. So you have to run a jumper cable, which is my little yellow wire that I showed you guys there, and I can actually show you that on a seat switch back here. So right here, perfect example. So this has to be a connected circuit, has to be completed circuit. So what you do is you just run a cable from one side of the connector to the other. That completes your circuit and essentially mimics a safety switch being engaged or disengaged depending on the position it's supposed to be in. But again, you're bypassing the safety switch by doing this. And now I don't recommend doing that and you know, operating your equipment, because it's, you know, dangerous. Obviously, safety switches are there for a reason, but for the purpose of, you know, diagnosis and whatnot, you can just bypass a safety switch. And sure enough, what I did, I bypassed that one and I left the one over here plugged in. see if I can get a shot of it for you guys, just to show you what they look like and how they're set up. So right in there, the blue wires. So again, there's your reverse switch, and when that goes down, it acts as a circuit breaker, so it breaks the connection between those blue wires. When it's up, the circuit is completed, which means unplugging those will actually break your connection and your machine won't be able to engage the PTO. So if you're unplugging these safety switches on the model ZT50, you have to run a jumper wire like that seat switch that I showed you on the Toro. So again, you know, electrical work can be a pain in the you-know-what. It's a lot of headaches, but if you get a wiring diagram and you just go safety switch to safety switch, then you can normally kind of do a process of elimination. And again, you know, if somebody brings me a machine and it fires right up and it drives like this one did, and he said the PTO didn't work, the first thing I did was test the PTO itself by putting 12 volts directly to the PTO. And same as the solenoid on that one, it's a little electromagnet on a spring, and sure enough, it clicked. You guys will be able to hear it. Okay, so I'm up under a zero-turn lawnmower right now. I got battery positive and negative going to 12 volts, and we're just putting 12 volt power to the electric PTO here to see if it clicks, just to test that it is in fact working. So you guys will be able to hear it click. So I knew right away that the PTO worked, so it had to be another issue. I've tested that, and again, that works. His old one didn't. So it's funny because he said he had a bad PTO switch. He replaced it. It worked fine, and then it stopped working. So he thought maybe he had a blown switch again, which would have been a voltage issue. You know, if you keep blowing your switch or a fuse, you have a short to ground somewhere, like a bare wire touching your frame or something like that. Whereas in this instance, he had a good PTO switch because I checked that one, the new one, and it was good. And it turns out it was just a safety switch, which was the left-hand reverse switch. And I can put a part number down below. I told him that for, I think, 12 bucks a piece or something like that, I'm going to order two just so he has a backup. Then there's also these neutral switches, but I know that they work because when I had the parking brake on, as soon as you lift one of these arms out, it kills the spark to the engine because it basically prevents you from driving with the parking brake on so that you don't, you know, wreck your transmission. So either one of the handles, when you bring them in, kills spark to the engine. But again, that's the engine circuit. We were dealing with just the PTO circuit, and on the PTO circuit, that is all dependent on your reverse switches. So again, you know, first thing I checked was PTO, second thing I checked was reverse switches, and sure enough, one of the two reverse switches were bad. So again, when you're dealing with electrical issues, you know, things can be a pain, but you just go step by step and take your time and you'll figure it out eventually. So I can see that just by probing the back connector of this safety switch, we do in fact have continuity. It's not the greatest, so there is a little bit of resistance in there. Could be rust or whatever, or I may just not be getting a good connection. But if I lift, I'll try to get a good shot of it here. If I lift this arm, it breaks the connection. So I know that that safety switch is good. See that? So again, not the greatest connection in there, but we know that the switch works as it should. So I can now rule out the blade engage safety switch. I know that works. I can rule out the solenoid itself. I know that works. Now I just have to check my ground and my positive coming off the battery, and then I'll also check the brake switch. Some of the seat switches kill spark when your blade is engaged. So if your blade's running and you get off your machine, it kills the spark. Other machines, you know, your parking brake has to be on. With the blade disengaged, you can get off your seat and it won't kill spark. But if your parking brake isn't on and you get off your seat, then it kills spark. So it all depends on the machine, I guess, and how exactly the switch is oriented. And I've now located the position of my brake switch. So those two little nuts on those studs there hold the brake switch on so that when you push your brake lever forward, it engages the switch. The only thing is it's on the inside of the frame rail, which makes it a little harder to get to. So what I'm going to try to do is I will probe the switch to determine whether it's open and closed when it's in the engaged position, and then depending on which way that is, I will either disconnect the plug or I'll disconnect it and jump it just to bypass it and then see if my engine turns over. And if my engine does turn over with that disconnected or disconnected and jumped, then I'll know that it's a faulty switch instead of going in there and, testing the switch. Okay, so a little update on the Toro Riding Lawnmower. I was going through a bunch of stuff here and I thought maybe it's a bad key switch because we went 12 volts directly to ground and the starter and this thing turned over. So we know that the starter itself works, and once the engine turned over, we got spark, and when you shut the key off, it turns off, which means that the ground from the key switch goes to the coil and grounds that out to cut out spark, thus killing your engine. But the problem is it wouldn't turn over with just the key switch. So I thought, okay, it's got to be a brake switch or it's got to be the deck switch down there. So I tested them and they tested okay. Then I went and manually tested the solenoid like I showed you guys earlier, and you can hear it click, so the magnet picked up. So then what I did was a continuity test between my negative and my battery negative back here. Let me just turn this off. And I got continuity. Then I tested from this red and I tested continuity to the battery positive, which is, it's like this one, I think, right there. And we had continuity there as well, which means that I know for a fact there are no blockages or added extra resistance between those wires. So then I'm like, okay, well, the solenoid works, the starter works. I then tested the key switch just to make sure that works, and the key switch works as well. I have, just so I can show you guys, I have the brake switch bypassed right now. So that's normally open. So when it's back, it's open, which means it's a circuit breaker. So you close the circuit when you press your foot down, which means that if you unplug your connector on your brake switch, you're gonna have to jump it like I have. And again, I'm just using these little wires that are bent like that to jump, just to test things out. So then, because it's a 4-post solenoid, this depends on basically having a ground wire to it and a positive wire to it. So I said, okay, well, maybe the key switch itself works, right? But maybe there's no power going to the key switch. So what I did was I took my multimeter and I set it to 20 volts DC, and I basically probed the red here, which is from the battery, and I just put the other end to ground. So I think I just grounded it to the starter. And sure enough, we had 14 volts when the Eliminator battery pack was on, which means that this is what's called a powered key switch. And if we look close enough, we can see here the orange wire that supplies your 12 volts to your solenoid once you turn the key to the third spring-loaded position. So basically all that does is it connects your 12 volt positive from your battery to this orange wire. So that's all you're doing. When you're in that third position, that spring-loaded start position, all it's doing is connecting these two wires here. So you're taking 12 volts positive from your battery and you're putting it into the orange wire, which goes down through the wiring harness all the way to your 12 volt positive. So I did basically just a continuity check between here and the orange, and we got continuity. Then I was checking the ground, and that's a green wire coming from there. Now I have some other wires coming off of it, and I'll get to that in a minute. So there's a green, and the green goes into this here, which on this mower there is a relay. Let me see if I can get a shot of it. So that black box, that pulls out, and you can test that, and I pulled that out, and essentially a relay is, it's just a switch, and basically after I did just a little continuity check between the two, it has a diagram directly on the relay, and it tested out okay. The one terminal had a little bit extra resistance onto it, but that's about it. So I thought, okay, if the relay is good, all my wires are good, the key switch is good, I know that I'm getting 12 volt to the key switch, and I know that 12 volts is going from the key switch down through the orange wire to the solenoid because again I checked that. Then I figured out, well, if everything else is good, then it has to be a bad ground on the solenoid. So here's your positive from your battery, and then here's your cable that runs to your starter. So then you would have basically just a 12 volt lead going to your key switch, and then the 3-prong ones, like I've done in my video, you guys can check that out, how to test a solenoid. Basically the 3-prong ones, they ground through the frame, so it bolts directly to the frame. On the 3-prong ones, if you ever have an issue with starting, chances are there's a lot of rust in between the solenoid and your frame. It causes added resistance, which basically that's like the first thing I checked. But when it's a 4-prong, usually you don't run into bad ground issues, so I kind of overlooked it. And that's, I guess, bad on my part, because what I've done here is I've hooked a little cable, and don't worry about that, that's just a little fuse in there. Oh, and by the way, I've checked all my fuses as well, and they work too. So what I've done here is I've just jumped my ground. So instead of relying on that green wire, wherever it goes into the loom, somewhere that green wire goes into that relay, comes out of the relay, and then goes somewhere probably to the frame, and it's a bad ground to the solenoid. So what I've done is I've eliminated the green by jumping it and taking a wire and putting it directly to the frame. So you can just see I just have an alligator clip holding this wire to the ground. So now when I take this wire and I jump from red to orange so that I'm supplying 12 volts from the battery to the solenoid, basically imitating the key switch turning into the third position, the engine turns over. And I can actually show you guys that. And I've got my throttle pushed all the way down just so that it doesn't try to fire up on me. But basically when I stick this in here, so I'm gonna have to turn my 12 volts back on, and then when I take this little jumper and we jump from red to orange, see that? So we're just imitating the key switch. So that's it, guys. So it's just a bad ground on the solenoid. And now what I can do is come over, disconnect my little ground jumper cable that I've fashioned. To fix this is just hook up a ground wire from the solenoid directly to the frame. And then I won't have to rely on that green ground wire, which is probably separated somewhere. So just by fixing that ground cable and jumping that, this machine turns over. So technically speaking, I could plug the key switch back in and fire this machine up. So I got my key switch here hooked up, and what I'm gonna do is just grab a hold of that like that, and we're gonna turn this engine over. Just like that, guys. So this machine is basically fixed. I just have to fix that ground wire to the solenoid, and you know, a little bit of electrical diagnosis. You gotta kind of go through all your stuff. So I just took my die grinder, ground some of the paint off, put a self-tapping screw in here with a connector, and ran a black ground wire to the ground of my solenoid. So that's all done. So this thing should technically be ready to go. So 2 different machines, 2 completely different problems, but same diagnostic routine. So if you start at one end, you work your way through the wiring harness and you test literally everything, eventually you will find your problem. Now, whether you'll find it at the beginning of your test or at the end, that's all dependent on where the issue is and where you start. So with this thing here, you know, took a little while because I tested the PTO and I ended up testing that reverse switch on the right side, which was fine, and I ended up testing the left hand reverse switch last, and sure enough, that was the one that was causing the issue. So like I said, guys, you just got to go through the diagnostic routine and you'll find your issue. Okay, so I'm just up under the 0-turn mower. I've replaced the left hand reverse switch. PTO engages, everything runs good, but if we look at that, see that? The belt has slipped off of one of the spindles. So thankfully, I should be able to get to that shroud, the covering there, and remove that so that I can move the tensioner in to release tension on the belt and then wrap that belt around the pulley. Why that came off, who knows? Maybe a stick got in there or something, but I never really noticed before because the PTO didn't work. And when I tested the PTO, the engine wasn't running, so the belt wasn't turning. So I never really noticed that. So I'm gonna have to fix that. And as soon as I fired up the PTO, I could smell a little bit of smoke. So that's exactly when I shut it down and had a closer inspection. So I got the cover off of the pulley here, and we can see the belt slipped off of the pulley and has been rubbing on the spindle. You guys always gotta check stuff like this if you see smoke. So because our idler pulley right there is on a spring, what you can do is just pull this belt back to about here, and then you start to rotate just like you would to try to put a chain back on a sprocket, and it'll work itself around. You could go either way. I went from this way, and yeah, that ended up getting fixed. So now I'm gonna go and just try to engage the PTO with this shroud off just to see if that slips off again, and if it does, then I'll know that there is some kind of issue on the other pulleys. And you also want to check to make sure all your pulleys are flat. So if one of your pulleys, like let's say an idler on an arm, is up like this on an angle, that can also make belts slip off pulleys. So I'll take her for a run and cut some grass and try it out. Works good. Well, I just cut my whole front yard in about less than a minute. That thing's pretty awesome. So I'll have to get this shroud back onto the deck. I'll write up an invoice and I can get this thing back to my customer. He'll be happy. Well, that's it for today's video, guys. If you enjoyed it, think about leaving me a thumbs up. You know, it really helps me out. You can click here to subscribe, and you can click over here to watch one of my previous videos. I upload every single week, so be sure to come on back next week and check the channel out for new content every single week. And as always, guys, thanks for watching.